What you will learn: install Ghidra on Linux and Windows, decompile and rename symbols, string searches, and also string creations from raw data, cross-referencing function calls and strings, identify entry points, main and min-main functions, stepping into and out of function calls, editing function signatures, function call trees, function graphs, Windows API, reversing command line crackbees, reversing graphical user interface crackmuse, using x64 DBG cheat engine with Ghidra, running Windows executables in Linux, creating functions and data, and much, much more. Who this course is for? This course is for complete beginners to Ghidra, and also suitable for those with some basic minimal experience with other disassemblers. Prerequisites: you need a Windows PC at least. Also, some familiarity with basic Linux commands is preferred. Knowledge of assembly and C language will be helpful, but not strictly necessary. Hello and welcome back. In this video, I will show you how to install Kali Linux in a VirtualBox. First thing we do is download VirtualBox from this link website here, select Window Host, and download it. Second thing is you download Kali Linux. You go to this link, this website, and you can use the ready-made, which I'm machines, which I'm using over here. So I click on Offensive Security VM download page, and I scroll down, and I click on this one to download. So you can download this directly or use the torrent. I use the torrent. So I click on the torrent to download the torrent file, and this is what I get. Then I open this torrent file in my BTorrent client, and I downloaded it using the BTorrent protocol. So now it is downloading. So, meanwhile, I go back to my downloaded VirtualBox installer, and I will install this first. So I double-click to start the installation of VirtualBox. Just click on the Next button, and click on Next. Take note of the location of the installation. No need to uncheck anything. Just click Next. Click Yes. He says he will disconnect you temporarily from the network. So we'll wait for the BitTorrent to finish first. Otherwise, we will lose connection. Now the BitTorrent has finished in downloading the Kali Linux virtual machine. We can continue with our installation of VirtualBox. Click Yes, and then click on Install. Take note that before you can install Oracle Virtual Machine, you have to enable virtualization in your BIOS settings first. So let's wait for it to finish. And it has finished the installation already. So now you click on Finish and it will start. If you don't want it to start yet, you can uncheck this. So I'll uncheck it and click Finish. So now I'm going to go to the down folder for Kali Linux and open the directory where it has been downloaded to. And this is my Kali Linux virtual machine VA extension. So I will just copy both of this. Or maybe I copy the whole thing. I will go up to the parent directory and copy the whole folder. I will cut the whole folder and then go to a new location in my C drive, and I'll create a new folder. So click on a new folder and then call it Kali Linux. And inside here, I will paste the virtual machine. Right, so now that is done, I can go and launch my VirtualBox. So my VirtualBox should be here. I just double-click to launch it. And this is my VirtualBox. Notice I already got 3 virtual machines from my previous work, but I'm going to create a new one. So a new one, you can import the virtual machine. So import appliance and local file system. Look for the OVA file. Go to Kali in the C drive and open this and click on it, open, and then click on next, and then here nothing to change. You will use the NET protocol to share your internet from the host machine, and then click on import, click agree, and the import has begun. Alright, has finished importing. It sometime, probably around 30 minutes to an hour to import. Now you can start it. So now it's powered off and you can start it. Before you start, let's check the machine settings. So you can go to settings here, select machines and settings, and check the network. Make sure it's enabled so that you can access the internet. Click OK. Click on Start and machine choose Tata. So when you see this, it's booting. Now you can log in. Let's try a different password. Kali, password, also Kali. So the login is Kali, the password is also Kali. Okay, so now you can view full screen mode. And there you have it. This is the full screen. So you successfully installed. Now let's see if we can go to the internet, look for your browser, Firefox, there you go. Yes, so Firefox has opened up. Let's go to the internet. Yes, so the internet is also working. So we've successfully installed this Kali on the virtual machine by importing the OVFR. To shut down the server, all you to do is click on this button here, log up, and then click on Shutdown. That's it. Thank you for watching. Welcome back. In this video, show you how to create a shared folder between the virtual machine Kali Linux and our host machine Windows so that we can share files between the two. First, we need to create a shared folder, so go to your C drive, scroll, and click on New Folder, and say Linux Share. And then now, we go to the Kali virtual machine. It should be Settings, so click on Settings. So under Settings, go to the Shared folder, click the Add icon, and click on the drop-down to click on the Under, and select the path. So go to your C drive, and select the Linux Share folder. Click Select Folder, and then click Auto Mount. Then click OK. So this should be All Access, Read and Write. So don't check this one. So click OK. And then click OK again. So it's Auto Mount. Make sure it's Auto Mount. And then now we can start our Kali machine and check the chat folder. Just log in with the username Kali. Password. Also Kali. And hit the login button. Now we can go to our file system and look for our shared folder. So we now shared is empty at the moment. So we can try to put something in here. We can right-click and create a new folder or create document, empty file. Test. Let's call it test. Okay, so now we have a test file there. We can just go to Windows and check it up. So I'm going to restore to Windows mode and hover to the Windows. And there's your test file. So let's try to edit it and type something inside it. Hello from Windows. Save it. Let's try to create a new file from Windows itself. Call it created from
Windows.
And then now we go back to Kali, and here we can refresh the page, the directory reload, and we see created from Windows, and here is it, testing hello world, and then over here. Okay, so it's working. This is how you can create a shared folder that can share files between Linux. Thanks to Windows. Thank you, Linux and Windows. Thank you for watching. Hello and welcome back. In this video, I will show you how to install OpenJDK, which is the Java Development Kit, and also the Ghidra. I'm now in the full screen mode in Kali. If you wanted to go back to the Windows mode, just hold your mouse at the bottom, and this 2-bar control will open up, and click on this icon here. And you go back to Windows mode. I'm going to go back to full screen mode now. The other thing you can do is Host F. Host F is the right control the keyboard, and F key will also take you back into Windows mode. So I'm going to open the terminal now. Click on this terminal here. And now we are going to do update to our package. Type sudo apt update. Press enter. So key in the password for sudo, which is Carly, K-A-L-I. Press enter. And now it is updating. We can go ahead and download the Ghidra. To download Ghidra, open your browser. You need to use a browser, so over here, just look for Firefox. Press F to search Firefox and click on the Firefox to launch it. Okay, so now we will key in the Ghidra, press enter, and then click the first result that you get. Now you can download Ghidra. Click on the link here to download Ghidra. Click Save File and click OK. Now Ghidra has download. Just click on this. Go to the download folder. Click on this. And this is a download folder. Now we extract it. So we just extract here, right click, and then select extract here. After extracting, there will be a new folder here. Just open it, and you will see inside there is all the salt folders and files that are needed by Ghidra. Now we are going to copy this folder or move it to the OPT directory. So before that, I'm going to rename this folder. Right-click, rename. Let's shorten the name. Ghidra 922.
Right.
So to move this to the OPT folder, I'm going to use the command line to it. Open the terminal emulator. And then I will go to the downloads folder. And then I'm going to copy recursively the Ghidra folder to the OPT folder. Press enter. Permission denied. So I need sudo. So insert sudo in front and press enter. Key in the password again, Kali, K-A-L-I, and hit enter. So it has finished copying. Now we can close Firefox. And we are ready to launch Ghidra. So let's move to the cd/opt and ls to check the content of the directory. And you can see Ghidra is there. Now we enter the Ghidra folder, press tab for auto-completion, and list the content of the directory. I will close the other terminal. So the content directory shows that there is Helera run script here. So this is probably the one we want to use to run our Ghidra program. So to run it, just put a /, type in Ghidra, press tab, tap here, press tab, and press enter. So it's asking for the path to JDK home directory. So let us try to install Java, since I could not find the machine. So I will type sudo apt install open and JDK, and I have all this. So I'm going to move So now we are going to... So after you hit sudo apt install open jdk11 jdk k and b password for the sudo, and it is installing. So press on yes to install. Okay, now that he has finished installing, let's go to our 0pt folder and tur the Ghidra folder again and run the Ghidra script. So Ghidra has detected the new Java which you install, and now you click on agree and success. So this is the first screen you see when you launch Ghidra. Alright, so we are successfully installed Ghidra, and this is the help file. This is the kit file, just click close. So that's it. So we successfully installed Ghidra. To close, just click on the X button. Thank you for watching. Hello and welcome back. In this video lesson, I'm going to outline the workflow. So the workflow is like this. I will provide the files for you to practice on, and you can download the file. After you download the file, you have the file's name, C1, C2, C3, C4, and C5. And there will be more as we go along. We will then copy all these files, every one of them, cut it, and then create a folder in C right inside the Nashi. And then inside here, we call the folder Session 1. And then inside, we paste all the crednist. Next, we head over to this Kali, and then go to the shared folder, which contains Session 1. We will then cut the whole folder and put it in our home directory, here. We see here. So now we have Session 1 in our home directory, and we can close the Notion folder. So, these files, Crackmez, written by somebody called Wrongboard. And these, the website, where I got it from and these are the files that I downloaded from his GitHub. So, to start off, we are going to try to reverse C1. Before we reverse anything, we want to try to run it. So we can right-click here, open terminal, and then we can right-click, we can try to run C1. If you type ls, we can see there are 5 files there. To run C1, just type C1, press enter. It asks you to supply the password. So this is a command line program. To supply the password, you must type C1, followed by the password, and it gives the answer, wrong answer. We'd never use 12122N2 as the password. So you have to keep on going until you get the right password. Still wrong answer. So now we are going to reverse it. So to reverse C1, we open our calculator, click the terminal, go to the Girdle folder, which is in the OPT directory. Type ls and you can see Ghidra Installation. Then type /Ghidra.run and press enter. And it will fire up Ghidra. Once it starts, you can close the terminal, leaving this terminal open. Create on close. Now we create a new project. File, New Project. Create a non-shared project. Dig in next. The project home directory. Click on the 3 dots and navigate to our home. Click on Home. Click on Section 1. Click Select Project Directory. Section 1 is our project directory. Then we give a name, project name Section 1. Click Finish. Now we can port the files into Ghidra. So the first file we want to try is C1, so we just go to the location of C1, drag, and drop it in here. And git robbit port. It has detected that it is an L file. IL file is a Linux binary, similar to the Windows P file. And it has detected this alpha, and the program name is C1. So now we click OK, and it will load it. It will import it. After importing, it will show you a summary, the name of the file, the name of the program, the language, and then over here, processor, and so on. Now click OK to dismiss this result summary. Next thing we want is to analyze it using the code browser. So we can double click on this or drag it and drop it in the code browser. He will then try to analyze the file. C1 has not been analyzed. Would you like to analyze it now? Click on Yes. And it will use the scripts in this list here to analyze. So no need to change anything. Just click on Analyze. And you can see on the bottom right the process, and it has finished analyzing. Now this is the Ghidra code browser. You have a few panels. Top left hand is the program trees. The program trees shows you the entire summary of the binary itself and the various sections. The second panel is your symbol tree, which contains all the functions as well as other symbols, libraries, imported libraries, exported libraries, functions, labels, classes, namespaces. And the bottom panel shows you the data type. And we can use this to make sense of the various structures inside the binary itself. And in the center panel, we have the dis and disassembly listing. And this is why it looks like the disassembly for the binder itself. And you will notice that It contains, the first column will be your memory address, followed by the bytes. And then you will have other information like symbols as well, as you can see from here. And all of these can be renamed as you analyze it. It will rename so that it makes more sense and easier to read. On the right panel is your decompiler window. This will try to decompile the code in here into C language. And bottom is a console for scripting. To start off, we want to look for the main function. So we go to the functions symbol 3, the functions folder, and expand it. And then we scroll down and start looking for a function, main function, and click on it. And it will disassemble and show you the result here, the main function. It will even give you a C function name. And on the right here is a corresponding, the compact version in C language. This main here refers to this main, which refers to the entire code, starting from here until then return at the bottom here. Then you start another new function here, all the way to the here, to the end of their code here. Then start another function, and here, and on. So each function that it has detected, you can click on it and view it in the C compiler view. So basically, this is how you use User. And on top here, there are other features we should be using as we go on. So that's all for this lesson. I just want to introduce you to a workflow that we'll be using when doing reversing. And after doing the analyses, if you want to close it, you can click on the X here to close it. This will ask you whether you want to save. Click Don't Save or Save. It's up to you. So we'll click Save. And now you're, save. So this is how we use Ghidra. So we'll continue with the reversing in the next lesson. I'll see you then. Welcome back. In this video, I will show you how to analyze the binary. So double-click on this to open the C1 binary, and it will show you the code browser. Go to the functions, fold down of a symbol tree, and scroll down and double-click on main. So now we can drag this and resize so that we can have a better view. And we can see from here that this is the main signature for the main function of a C program. The main function will accept two parameters, argc and rv. Let me just refresh your memory about C program functions. This is how a main function signature looks like. The first parameter is xc. xc means how many parameters are there. For example, if you were to run this program, you can click on the tab up here for the windows that we initially open. So when we run this program, that's C1. If there are two arguments, that C1 is the first argument, and the parameter is the second argument. So x is 2. That is the meaning of xc. The second parameter is a list of string. So it contains a list of the argument. So in this case example here, the first argument is the name of the boundary, which is rv0. And the second parameter is the name of the first parameter to the argument, to the binary itself. So if you were to use the example just now, rv and rv RV0 will be C1. RV1 will be 32323. Okay? So this is how it works. So over here we can see that the signature is wrong. It's supposed to be like this. So we have to edit it to change it. Just right-click on this, edit function signature, and we can change the signature directly to Huxley, argument count, and for the second one, we will change it to Chua. Okay. So the 2 stars there means that this is a array of strings to correspond with this. So these 2 are equivalent. We can't use the square bracket in here. So we need to put 2 star in here. So now it's correct. Hit enter. Click OK. And you can see now it's correct. And then over here also you notice some other changes that reflect this name. Now if I undo this, you can undo it by Ctrl-Z. You can also undo here and redo here. So before I renamed the signature, it was like this, hard to read and makes no sense. But when I re-edit the signature to become the correct main program signature, this still makes sense. So you can see here, the program here is comparing whether there are 2 arguments.
Right.
If there are 2 arguments, then you will enter the loop, enter the block here. And the first thing it does is to get the length, the password. So this is the password that it is looking for. So we know that this is a length. So we can rename it. Right-click, rename variable. The shortcut is the L key. Then we can rename it as length. So now it's easier to read. And then after that, once it has got the length, it's going to string and compare. String and compare. So if you don't know what this means, you can always refer to the tutorials point and search string and compare. And you can click on the first result and you can read all about it. String and compares 2 strings, string 1 and string 2, or up to the n number of characters. So if you specify 3 characters, it would compare 3 characters here and here. And this is an example. So in this case, you have 2 strings, string 1 and string 2. String 1 is lowercase a, b, c, d, e, and f. String 2 is uppercase. So when you call string and compare, it's comparing the first 4 characters of string 1 and string 2. So it is comparing A, B, C, D from here, A, B, C, D from here, and returning the result. If just the 2 strings matches, it will return 0 as a result. So 0 means the strings are identical. If the strings are not the same, it will either return less than 0 or bigger than 0. So this is how string and compare works. Now applying this knowledge to our analysis, the string and compare here is comparing the user input harv1 with the password and is comparing it for the length. So the length of this password is provided by string length. So the length should be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 character. 9. So he will grab the first 9 character of your input, LP1, and compare it with the 9 characters from Hackaday. If they are identical, then the result will be 0. So we know that this, the result of the string compare, we can relabel it by right-clicking and rename. Then we can call it result. Straight away, it's easier to read. And if the result is 0, that means the user has entered the correct password. And so it will print correct. The password was this the whole time. Right? This is a format specifier in C language. So whenever you see %s, it means that it will substitute this variable inside here. So and print the original password in here. So let's try it out now. So we know the password must be this. So let's go out to our terminal and try la. So now we are going to enter this password, Hackaday. You hit enter, and it prints out correct. The password was Hackaday this whole time. So this string is coming from here. And this %s is coming from here. So this %s is the password itself, which is rv1, which you entered up here. So our v1 is the argument to the binary. Hal v0 is the name of the binary itself. If you had 2 parameters, then the second argument will be al v2. v0, al v1, hal v2. This is how the second parameter works. Alright, so now we have saw crack me 1. And this is basically the technique of analysis in Gödel. We will try to analyze the decompiled code and rename the labels until it makes sense. So now this is almost like the originally decompiled code of the original C program itself. And it's much easier to read than the assembly version. And so that's all for this video. Before you close, click on save. Click on save. Save all. Okay, so when you close this and reopen again, all your relabeled items are still there. You have not lost it. So if you go back to the functions main and reopen main, you will see that the rename labels are intact.
Right.
So that's all. I'll see you in the next one. Thank you for watching. Hello and welcome back. In this lesson, I will show you how to create snapshots. This is Oracle VirtualBox. As you can see, in the earlier lesson, I have showed you how to install Kali Linux.
And
if you click on Kali Linux Virtual Machine, you will see that over here, there is a list of all the snapshots. Snapshots are a record of the current previous state of a virtual machine. If I select an earlier virtual machine, for example, Windows 7, you will see that I have a list of snapshots. If I wanted to revert back to an earlier state, I could easily select the snapshot that I want and then click on Restore. And then it will ask me to confirm if I want to restore. If I wanted to restore, I would then uncheck this box and click on the button Restore. After that, it would then undo all these other later states and go back to the state of the virtual machine as of this snapshot. So this is very useful because sometimes when you are doing reverse engineering, you might want to undo any changes that has been made to your operating system in the virtual machine. Sometimes a tool or a program which you install might alter or make changes to your operating system. For example, it might modify your registry settings or create other files in unknown locations. So the easiest way to undo all those changes is simply to revert back to an earlier snapshot. This is especially useful when you are trying to learn reverse engineering and want to undo changes made by the software. It is also useful in malware analysis when you are trying to analyze a software which you suspect might be a virus or some Trojan. So, or even ransomware. So in order to undo the damage done by the virus, you can easily revert to an earlier snapshot. So how do you create a snapshot? We are going to try it on our Kali Linux virtual machine. The first step is to select the virtual machine. And then, over here, on the toolbar, you will see an icon, a button called Take. If you hover your mouse over it, you will see the text Take Snapshot. So all you need to do is just click on it. Then it will ask you for a name for your snapshot. So we can give it a name. We can give it a date even if you prefer to call it by date. So I can call it to 1 March 7, today's date. And I can put in some description if I wanted to. And if I didn't want, I can just leave it empty and then click OK. And now it has created the snapshot. I can then start my virtual machine. I will now log in using Kali as a login name and Kali as the password, and hit login. I will now go into full screen mode by clicking on View and selecting Full Screen Mode. And then I will click on the Switch button. I will now demonstrate how to create a file and then undo it by reverting to the earlier snapshot. So I will now right-click here and then create a folder right on the desktop and call it Test and click Create. And now I have a new folder on the desktop. Open the folder by double-clicking it, and inside this folder I will create a document, an NT file. Call it test file. txt. So now I'm going to undo this by reverting back to the earlier snapshot. So to do that, I will now shut down this Kali machine. First, I will restore it to its windowed mode by hovering my mouse at the bottom so that the toolbar will pop up, and then selecting on the Window Restore to back to Windows mode. And now I will shut down Kali by clicking this button on the top right corner and hitting Shutdown. Now my Kali machine has shut down. So, as you can see, when I select on the machine, I can see that the current state has changed. So, if I wanted to undo this change, all I need to do is select the previous state, and then hit the Restore button on the top. It will ask me to confirm. So, I will uncheck this box and click on the Restore button. And now you will notice that the current state has updated to the 2021 March 7th current state. So I can now restart my Kali machine and check it up. My Kali machine has fully booted up. You will now notice that the folder which I created earlier is gone. So this is how you can use snapshots. So use it often when you are reversing software. So that is all for this video. Thank you for watching. Hello and welcome back. In this video, I'm going to show you how to reverse C2 and also how to configure Ghidra to highlight all similar selected labels. I have my Ghidra open, so I'm going to drag C2 into the session 1. It has detected the format to be ELF file and also 64-bit program. Let's click OK. And this is the import result summary. Compiler ID GCC, Little Endian, address size 64-bit. Let's click OK. I'm now going to analyze it. Just drag C2 into the code browser and release. Ghidra will ask, C2 has not been analyzed. Would you like to analyze it now? Click on Yes. Ghidra will use all the listed scripts to analyze. Click Analyze. No need to change anything. And the bottom right corner shows you the status of the analyses, and it has completed. Now go over to the Symbol 3 panel and look for the Functions folder. Expand on the Functions folder and scroll down to look for the main function. Click on the main function, and Ghidra will show the disassembler view in the center panel. And in the right panel is a decompiled view in C language. The parameter for the main function is wrong. The signature is wrong. We are now going to correct it. Right-click on the main function and select Edit Function Signature. Change the param1 signature to argc for argument count, and for param2, let's change it to an array of strings cha star star kv. Sweet. OK. Now we will notice the updated changes propagate to the parameters as well. Over here, in this line, we see that it is comparing the program command line to see whether or not there are two parameters. So let us try to run first and see what it does. Click on the terminal to open one. Close that. We will use the file manager. Over here, right-click on this. You can reach this folder by clicking on the Home button, on the Home icon, and then selecting the Session 1 folder. Double-click on it. To open a terminal in this location, right-click and select Open Terminal here. We can now run C2. Without any parameter, it will display a message saying, "Please supply the password." We are now going to supply a parameter of 3A's. And we get a different message saying, "We'd never use a password that short." So let's give it a longer password and hit Enter. And it now says, "Wrong answer. Try again." So let's head back to the code browser. You can select the code browser from here and scroll down and select Code Browser. As you can see, argc is testing whether there are two parameters. In this example here, there is only one parameter, so xc is 1. So, in this case, because xc is not 2, it will not execute this part. Instead, it will glue the else part and put a string. Puts is a function to print a string. It is also known as putString, hence BUDS for putString. You will put the string print supply, please supply the password, which you see here. In the second run, we supply a password, AAA. So this time, argc is 2 because there are two arguments. So it will enter the if block here instead of the else part here. It will then use the string length function to calculate the length of the input. The length of the input is stored in v1. E1 is referring to AAA. argv0 is referring to the name of the program itself, which is C2. So if you wanted to extract what the user typed in, you must specify argv1, which is here, argv1. So that is the meaning of the second parameter to the main function. So it will calculate the length of the parameter and store it in this variable svar2. So we know that svar2 is a variable that stores the length. Therefore, we can rename it. Just right-click on this variable and select Rename Variable. Alternatively, you can also press the L key on your keyboard. The L key is a shortcut for renaming variables. Just click on this, and now you can rename it to something meaningful. Length. Now, when reading this line, it is easier to understand the quote. Now, when you click on length, this part is not highlighted. It would be nice if all the length were highlighted, so that it is easier for us to do analysis. You can normally highlight all the similar variables by the middle mouse button. But sometimes it doesn't work. So in order to fix that, we want it to highlight all the variables that we selected by using the left click instead of the middle mouse click. To do that, head over to the Edit menu and click on it. And then select two options. Over here, scroll down to Listing Fields folder and expand on it. Down here, scroll down and look for the property called Cursor Text Highlight and click on it. On the right, you will see that there is a few settings that you can set. The first one is to enable cursor text highlight and the color that you want to use. And a third line shows you which mouse button to use. Currently, it is set to middle. Click on the list box here and select left. And then click Apply. You can also restore the default settings if you so decide. Now click OK. This time, when we click on a variable or a label, it will highlight all the similar variables inside the code listing. So this is how you can set the Ghidra to highlight all similar selected labels. So that is how we do this, and I will stop here for this video and continue with the analysis of this code in the next video. Thank you for watching. Hello and welcome back. In this video, I will show you how to analyze this code and solve it. In the previous lesson, we have already determined that the string length will extract the length of the password which you key in. So, the length variable, which have already rename it to, stores the length of the password which you key in. In the next line, it compares whether it is less than 5. So if your password length is less than 5, it will show the message, "We never use a password that short." And that is what happened in this example when we key in a password length of only 3 characters. It showed this message. That suggests that the password is 5 characters or more. So, in this next session here, we try the password, which is more than 5 characters. This time he got a different message. So, he went on into the else part and did some checking. And this time, when he checked your password, it was checking to see whether the first character of the password begins with the letter H, and whether the 5th character of the password begins with the letter U. So this is the first character. This is the first character of the password, and this is the 5th character of the password. Let me explain how it works using Notepad. When you enter your password, it will be stored in argv1. Assuming your password is A. The first character of the password is argv1 0. Let me use a different password. Let's say you have entered A, B, C, D, and E. So the first character of the password is the character A. The second character of the password is argv1 1, which is B. The third character of the password is argv1 2, which is C. The fourth character of the password is argv1 and 3, which is D. And the 5th character of the password is argv1 4, which is E. This is a notation in C language for two-dimension array. A two-dimension array is just an array of strings. So the first string is argv0, which is the name of the program, which is C2. So argv0 is the name of the program itself. That is how it works. And to make it complete, I will just list down argc. So in this CrackMe, argc is 2 because it has two parameters, c2 and the string for your password. And then in the string itself, that is two strings. The name of the program is the first string, which is argv0, and it is c2 in this case, whilst the second parameter, the second string, is argv1, which is the password you key in. In this case, an example would be ABCE, let's assuming you had typed A, B, C, D, E. So, this is the meaning. argc and RV. So in this case, in line 15, after it has confirmed that you have key-in password of at least 5 characters, it went on to check whether your first character is H. But notice, here it doesn't use out v10. How v10 is supposed to refer to the first character. Instead, it uses a star in front. It is actually the same thing. So, another way to refer to the first character of a string is to use a star in front of v1. So this also refers to the first character of the string. It's the same thing. Then, this is a logical AND operator. It means that both this condition and also the second condition must be true before the whole expression is true. So, the first character must be H, and the fifth character must be U. So 4 here refers to the fifth character, not the fourth character. Why? Because in C thrice, the first element of the array begins with 0. So the fifth element will be 4. So the first character of the string is element 0, whilst the fifth element of the string is element 4. So this suggests that it is trying to check whether your password that you enter has H and U in the first character and fifth character, so the password should be any password with the first character H and the fifth character U. So you can type in any kind of password. For example, 5-character long with the first character H. The second character can be anything you want. But the fifth character must be a U. So this is the password. Let us check to confirm that it is correct. So we are going to key in now. Each has a first character, followed by, and the fifth character we are going to put U and hit enter. And we get a message saying it is correct. Maybe we should pay attention to more characters. So this string is coming from here. So if you had entered the correct password that satisfies the length of at least 5 characters, and also the first character must be H, fifth character U, then this condition is met, and it will put the string correct. Maybe you should pay attention to more characters. So this is how we analyze and reverse and analyzed Crack Me in Ghidra. I hope this was easy to understand. And that's all for this video. Thank you for watching. Welcome back. In our next Crack Me, which is C3, we are going to take a look at how to use the understanding of ASCII code and hex numbers to solve it. So if you want to give it a try, please pause the video and give it a try. So this is how I solve it. Drag C3 into our session 1. It has detected it as an L format, 64-bit. This is the result of the import. Click OK. Drag C3 into the code browser to begin the process of analysis. Click Yes to analyze. Click Analyze. Watch the bottom right corner to see when it has completed. Now it has completed the analysis. Head over to the Symbols table and expand on the Functions folder and look for the main function. Head over to the Decompile window, and this is your main function. Let's change the signature of the main function. Let us rename this first parameter as xc and the second parameter as cha, sta, ha, we. Now we'll try to run the Crack Me. Go to the desktop and open the Crack Me. Open the terminal here and let's run C3. C3 without any parameters will yield the string, please provide the secret password. Go back to Ghidra code browser and you will see that C3, if it's run without any parameter, will yield this message. Please provide the secret password. Click on the terminal again. This is because of the check here. If xc is not 2, then it will show this message. So because xc in this case is 1, so this condition is not satisfied, and it jumped to the else part to show this message. Now we will provide an argument, 3 A's. And now we see a different string. This time we have satisfied the condition for xc. X's 2. So this is true. And so it enters the block and does these instructions. The first line, it will get the strength string length. Then, over here, it will store the string length to this variable, svar2. Therefore, we know that svar2 is a length. Let's rename to length. Our v1 is the parameter we pass to the program, which is the string AAA. If the length is less than 5, then it will show this string, which is appearing here. Now the length of our string is 3, so this is true. That is why it is showing this. So let us try now with the length of 5. Since it is expecting your password to be 5 characters or more. So we type in 5 A's, and this time we get a different string as the message. So in this case now, this test is false, so it skips the else if part and goes to the else part and perform this second test. Now in this second test, it will minus this from here and see whether the result is 0x20. So it is trying to extract the third character of your password and then minus that from the fourth character of your password and check to see whether the result is 0x20. 0x20 is hexadecimal. We can convert it into decimal by using a programmer's calculator. So select hex 20, convert into decimal. He sent to. That means it is taking the third character, minusing the fourth character, and see whether the result is 32. So how can a third character minus a fourth character give you 32? The answer is if the third character is an alphabet and fourth character is also an alphabet. So in an alphabet minus another alphabet, it means that we are minusing the ASCII code. Every character is encoded with ASCII code. So the character for every alphabet has a corresponding ASCII code, as you can see here. So if your first character is 97, 97 minus what gives you 32? That is the equation we need to solve. If the first character, a third character here is A, and the fourth character is a question mark. So a minus question mark. What character should this question mark be so that you can get 32? If you look at the SK code, A is 97. So 97 minus what gives you 32? You can solve it as an equation. So, in order to know what is the question mark, we can solve it this way. The question mark is equals to A minus 32. And that gives you capital A over here. capital A 65. A is 97. 97 minus 32 gives you 65. So 97 minus 32 gives you 65. So 65, you look here, is capital A. So to solve it, A minus question mark equals 32 is actually A minus capital A. That gives you 32. So using this and replacing it back in here, third character is lowercase a, fourth character is uppercase A, and we get this as the password. 1, 2, lowercase a, uppercase A, 4, 5. What is important is these two. 1 and 2, 4 and 5 can be any number or any character. It doesn't matter. What matters is that your third character minus the fourth character must be 32. So you can have more than one answer. It doesn't have to be A and uppercase A. It could also be other combinations of ethy character, so long as the difference between them is 32. So let's try this out to see if it's correct. I will try this again. This time I'm going to put 1, 2, lowercase a, uppercase A, 4, 5. And this time we see a different message, which is coming from here. Correct? You figured it out. So this is how we can use the understanding of cat ASCII code and hex numbers in order to solve this crack me. That is all for this video. Thank you for watching. Hello and welcome back. In this video, I will show you how to step into functions and also how to step out of functions, how to do commenting, and also how to convert hex into decimal, and show it inside the disassembly as well as the decompiler view. So let's open our home folder, open the section 1 folder, and then this is the crackme we are going to do C5. So let us first run C5 and see what it does. Right-click and select Open Terminal here.
And
Just run C5 without any parameters. It will show you a message, C5's serial. This is something like usage, telling you how to use the program. So now we will put in a serial. Let's say we will put in 1, 2, 3, 4, 5, 6, 7. It's as bad serial. So now we know the behavior, we can start to analyze it. I will import it into Ghidra. It has been detected as an alpha 64-bit assembly binary. Click OK. This is the import result summary. Click on OK. And then drag C5 into the code browser. to begin the analysis. Click on Yes and click on Analyze. Watch the bottom right. It has finished analysis. Now, head over to the Symbol Tree panel and expand the Functions folder and click on the Exit Main. Click on the main function. Let's edit the function signature. Right-click and select Edit Function Signature. Change the first param name to axc and change the second param to char star star act play. Hit OK. On line 8, it is checking whether your argument count is not equal to 2. If it is not equal to 2, then it will call a function, call usage, followed by argv, star argv. Star argv is argv0, and that is the name of the binary itself, which is C5. Let's analyze the output again. In this run here, we call C5 without supplying any parameters. So RC would be 1. So if RC is 1, this would be true. And so it would then call this usage function, supplying the name of the program itself, which is C5. So now if you wanted to step into this, we can just double-click on it.
And
We have entered the function itself. So this is how you step into a function. And if you wanted to step out of the function, we can use this back button here. And the shortcut is alternate left arrow. So we click on this now and we come back out of the function. So let's go back inside again. We know that this one is RV0, which is the name of the program itself, which is C5. So let's step into it now.
and
This one here, since we know that this RV0, we can rename this. Right-click, rename the variable as RV0. And this one we know it is a char pointer, char string, so we can right-click and retip the variable as char star and hit enter. Now you see, in the block of code itself, it calls a printf function, and the first parameter is %s, is a format specifier. It will substitute the %s, which the Harvey0, which you supply to the function. And since we know that Harvey0 is C5, so it will take C5 and insert here, and then print out the whole thing. So this is how we get
this
message. C5 followed by serial. And then it will exit, passing -1 as the exit value. Normally, -0, -1 is error. 0 will be success. So it will exit this without continuing in the rest of the program. Now we can go back. Then again, sometimes you might need to hit the back button a few times to step out of the function. That is because the back button detects how many times you left-click in the mouse. So, for example, if you entered the usage function and click somewhere else in here, then you will count how many times you click in here, and then you have to click the back button that same number of times and to get back out of it. So, if you know now that this usage function is just to show you how to use the program, now we can write a comment to explain that. In order to write a comment, we can right-click here, and then select Comments, and then select Set. And you can also pre-comment. For the decompiler window, the only comment you can set is a pre-comment. So click on Set Pre-comment. And you can see here there are several tabs. Pre-comment has been pre-selected for you. So here we can type a pre-comment saying that we try to explain this function. So we can say shows usage C5 serial. Now when we click OK, you can see the comment there. The comment is also reflected in this assembly view over here. Shows usage. Now we are not able to enter an end-of-line comment and a block comment inside the decompiler view. If you wanted to delete this comment, just select this, right-click, and go to Commands, and then here set pre-commands, and delete everything. If you delete everything, and click OK, the comment is deleted. So I'll just undo that to reinstall this. To undo, just hit Ctrl-Z on the keyboard. You can also undo here. Edit, Undo. Now, there are other commands, for example, plate command and online command. Let me show you. But plate command and online command can only be inserted for the disassembly view. So if you wanted to enter a black command, you can select a location in your assembly view. For example, if you wanted to add per place comment looks like this. End of line comment is a comment at the end of the line. So for example, if I wanted to add a plate comment here, so I will select this one, this call, right-click, and then Comments. I have set plate command. I can also select Set, and then from here, choose the plate command. Ensure I say type plate command. And then click OK. And now you see a plate command here. Plate command does not appear in here. Even if you were to insert a plate command here, it will show up in here instead of in the decompiler view. The other comment is the end of line comment. So if you want to add end of line comment at the back of this line, this is the end of line comment. So if you want to add the end of line comment here, you can right-click, comment, select EOL, end of line comment. You can also select Set and choose EOL. And then here you type EOL comment. And click OK. And you have EOL comment. Notice that EOL comment also does not appear from the decompiler view. If you were to try to set an end-of-line comment here, by doing this and set EOL command, here will only appear in the disassemble view. It won't appear here. So for the decompiler view, decompiler panel, you can only set pre-comments. You cannot set other comments. So if you want to undo a play comment, just select the play comment and go to comment, delete play comment. Or you can click on set, select the play comment, tap, and then hit the backspace to delete it, and the play comment is gone. Select similarly if you wanted to delete the end of line comment, just select, right-click the end of line comment, and then go to the comments, and then delete end of line comment, or you can go to the set, and then choose the tap for end on line, and then hit the back button to delete it, click OK. And end of line comment is gone. So this is how you insert comments into your code browser workspace. So in this video, this is where how I will stop now. I will show you how to continue with the analyses in the next video. Thank you for watching. Now that you have learned how to step into functions and step out of functions, how to do an undo, and also how to insert and delete comments, let us continue with the analyses of this grammar. And so this is the main function. Over here, if your argument is count is not 2, it will show you the usage, and once it enters usage, it will exit the program. So I enter the usage now. After printing the usage message, it will call the exit function to exit the program, and it will not continue. Let's step out of the function. But let's assume you have entered 2 arguments. So in this case, you have entered 2 arguments, C5 followed by a 0 number. So it satisfies this argument count, so this part will not execute. It will instead go to the next line and call another function called checkSerial. CheckSerial will pass the serial key that you entered, which is this case is 1, 2, 3, 4, 5, 6, 7. Argument 1, argv1, is actually your CA key, just like rv0 is your binary name, C5. So now let's go inside and see what this thing does. So to enter the step into the function, we double-click on it. And here we see cha param. So we know that cha param is rv1. Just check again, hitting back. I'll be 1. So we can step into this, and we name this as rv1. So right-click on this, and then rename variable as rv1. Or, if you want to be more descriptive, you can straightaway type serial. So you know that this is the serial key which you entered. And then, in here, it will use the string length function to count the length of the UC key which you entered, and it will store the result in a variable called svar1. So from here we know that svar1 must be the length. We can rename it, right-click, and rename the variable as length. So now when you click on length, it will highlight all the similarly selected variable or label. And you can see this length is being used in multiple places in this function. Now, on the next line, which is line 10, it will then check whether your length is equal to 0x mon0. 0x prefix means that this is a hexadecimal. So to convert this into a decimal number, we can use the calculator. select the programmer's calculator, and for the hex, select hex, and then type in here 1, and then click on decimal.
and
It is 16. So now we know that this is 16. It is checking if the length is 16. So if the length is 16, then your serial number length is correct. So this suggests that it wants us to enter a serial number which is 16 characters long. So we can actually convert this into to show decimal number. So to convert this to show decimal number, select this by clicking this, and then go to the This Assembly view and look for it here. It's highlighted in light blue. Whatever you click here will be highlighted in light blue. For example, if I click on this, it will highlight this part. If I click on this, it will highlight this part. So if I wanted to select this, I'll click on this, and I like this one in light blue. So now I can right-click on this and select Convert from the bottom here, and then select Sign this one 16. So select this one. Unsigned means there is no negative number. It is only positive numbers. So now we can see, once we have converted it in the disassemble view, it is also changed and reflected in the decompiler view. Now it's easier to read. And then, next one will be the while loop. The while loop, in this case, accepts two parameters. Now this is quite unique. While loop can have one parameter or can have two parameters. So, while loop, in this example, the while loop accepts two parameters. So in this case, the first parameter they access is to assign something to length. So in this case, it is assigning the length of the zero number. And then, maybe the length is 16, for example. And then, the second parameter here, it is checking whether local 1C is less in length. So here is checking local 1C is less
than length.
So how do we understand the meaning of this? Notice that the first parameter is separated from the second parameter with a comma. That means it will perform this instruction first, then only do this instruction. So in this case here, the first instruction is just to assign 16 to the length, because we know that it requires your length to be 16. So definitely, string length will return 16. So this will not change the operation of the while loop. The while loop will continue to move on to the second loop, second parameter. Now if we check whether 1C is less than 16. If it's less than 16, it will enter the loop and do the loop inside here. If your local 1C is not less than length, then it will quit the loop. So this is how you can understand this. So the first parameter is merely expression to perform some assignment. You can actually, it's similar to writing length outside here. And then taking away this part. So it's the same actually. Same. Alright, so in this case here, the compiler has put this statement inside the while loop, and separate it with a comma. Separate it with a comma with the second parameter, so it performed the same action. So now what is this local 1C? Just ignore the long U long here. The important part is the variable name. So what does local 1C do? When you click on local 1C, it will highlight all the occurrences of local 1C. And you can notice something here. Local 1C is used inside every element. So this suggests that local 1C is an array index, and you can confirm it by looking down here. Here is where you increase the value of the array index by 2, and then go back to look again and check whether it is still less than length. So this is just a way of going through every element of the array. The array is serial. Serial is a number, is a serial key which you entered. So knowing that this is an array next, we can rename it, right-click, and then rename it as ArrayNext. This makes it easier to understand our code when we are doing analysis. So now we know that it is now checking, in here the if statement is checking whether each character of the array minus the next character, because is +1 here. And then when you minus the second character from the first character, is the result not equal to -1? If it's not equal to -1, that means your serial number is wrong. Immediately, it will return. That means exit the loop. So this is the algorithm for your serial key. And this is what it means what it looks like. So now I've used I to represent array index. So it's easier to read. So in this case here, it is trying to compare whether the first character minus the second character is not equal to -1. So assuming that I entered a 0 number like this, I, when it first enters the loop, will be 0. So when I0 is assessing the first 0 key character, and it will take that first 0 key character minus I plus 1. I plus 1 is the second 0 key character. So it's trying to check whether 1 minus 2 is equal to -1. If it is not, then sit the way he will quit by returning. He will not proceed with the rest of the loop. So this suggests that in order to enter the correct sequence, your first character must be less than the second character by 1. So that when you minus it, 1 minus 2, you will get -1. After that, it will go down here, and then it will increase your array index by 2. So when you increase array index by 2, it will now become 2. I will be 2. When you first ran, I was 0. Now, because you plus 2, I becomes 2. So now it will test 0, 2, minus 0, 3. That means it will take 0, 2, minus 0, 3, and see where is -1. 0, 2 refers to this tree. 0, 0 is this one. 0, 1 is this one. 0, 2 is this one. Okay, so I2 means 3. It's referring to 3. And you take 3 minus 4, and then check.
Alright.
So because 3 negative 4 is -1, that means you are correct. Then it will go and increase the index by 2 again. And then now you are going to test 4 and 5. So 4 and 5 refers to 0, 1, 2, 3, 4 is 2. 5 minus 6. So 5 minus 6 is -1. Then you increase by 2 again. So you check. 7 minus 8, is it -1? Yes, it is. Then you check. Increase by 2 again. That means you check this and this. Is it -1? Yes, it is still -1. So you must make sure that after A, you must start from 1 again, so that when you minus 1 minus 2, you still get -1. And then the total length must be 16 numbers. So this is your password. This is your serial key. Okay, so now you can test it out. You go to here, and then you type in 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8. 16 characters, and hit enter, and you get good 0. Good 0. So let us trace this thing inside here now. How does it get good 0? Notice here, if you're, anytime it check the checks and find that the moment it detects that the serial is wrong, it will return this number. What is this number? All F. In hexadecimal notation, all F means -1. It is based on the 2's complement notation. You can go and read up on the internet. 2's complement. Two complement notation is a way for the computer to show negative numbers. Okay, so you want to show negative numbers. Like, for example, here. When you get all 1s, it refers to all F's. And then, when it's all 1s, that means there is a negative number. All right? So, that is the meaning of 2's complement notation. We are using binary numbers to represent sign integers. So, when you have a negative number, you put negative, you put S in front. The most significant bit will be S or 1. This indicates that it is a negative number. If it's all F, then for sure is -1. All right, so no need to go too much in there. Just to know that when you see all F, it means -1. So when you return -1, it will return to the caller of this function. Let's step out of it. So here, if you return -1, then you know that something bad has gone wrong. Something bad has happened. That means your stack key is wrong. So you can actually put a comment here to say that if the return value is -1, it means wrong serial key. So this one, since you know it is a wrong serial key, you can rename this variable. Okay, so just rename it now to return value or return integer. And then over here it checks if your return is 0, then put good 0. So that is what we are seeing here. Good 0. That means we return 0. Right? But if your return was -1, this would not be true. Instead, it will run this part and put bad 0, which we saw here. So 0, a return value of 0 means your result is correct. If a return value of -1 means your result is wrong. So let's go back here and see what makes it return 0. Check on this. So over here it returns 0. Here it returns -1. So in here, the moment the wrong serial is entered, straight away it returns -1. So if it doesn't return -1, then it will continue to check all the remaining characters until it finishes. Once it finishes, it will quit the loop and come out here and return 0. So we know that this is the return value. See this? Return 0 var 1. So we can actually right-click on this and rename it as return integer. See that? So when you return 0, it means you have successfully entered the correct 0. So when you return 0 here, and you go back out of the function, the 0 will be returned here and stored here as 0. And then when it comes here, it will check return 0. The return integer is 0, so this is true. and it shows you the good message. So this is how to solve this criny. That's all for this video. Thank you for watching. Hello and welcome back. In this video, we are going to reverse another Windows GUI Crack Me. So go ahead and download the GUI Crack Me, which is called Autogenferial, and then create a new folder in your home directory and put it in this tutor, put here. And now we are going to run it and see what it does. Right-click and open terminal here. And let's run it let's first test it with file to see what is zero. So it is the EE32 executable GUI program, meaning it's a Windows program. So we're going to run it using wine. And this is what it looks like. Enter first name and serial. So let's put and you get the bad message. Wrong serial key. So now we can start to reverse this. We are going to create a new project in Ghidra. Select the folder for the new project. And then give it a name. Let's call it Autogen-Serial. And click on Finish. We'll import the file. So just drag it and drop it into the new folder. And it has correctly detected it is a portable executable. It is a 32-bit program written Boolean. Let's click OK. Now it's undergoing the process of importing. And you get the port result summary. Click on OK. And here you can see also the compiler is Boolean. Processor x86, 32-bit. Boolean C++ compiler. Click OK. And now we are going to start the process of analyzing by opening with Code Browser. So drag it and drop it on the dragon. Click on Yes to analyze. Over here, select the compiler parameter ID. Uncheck PDB Universal. Check on Windows PE. Propagate External and click on Analyze. Let's close this. And keep an eye on the lower right corner to know when it has finished analyzing. All right, after a few minutes, it has finished with the analysis. So we can now go and look for some strings, which we saw earlier, wrong serial key. So head over to Search for Strings. Click on Search. And now it has got a list of strings, and we can filter out crown. And there you go, it's a unicorn. Wrong serial key. So just double click on that, and we can dock this by dragging the bottom blue bar to the right. And this is where wrong serial key string is found in the listing. Wrong serial key. And you also have error, and you also have correct key, and well done. And something interesting here, it looks like a format specifier. Could this be the Sigma key, the actual Sigma key? And you can go there and take a look. There's a cross-reference there to the function which refers to this. So we can double-click on this to head over to that location, and we can see more of it here. It is contained in this function. And if we head over to the decompiler window, we can see it here. And you scroll down, and take a look. You get the if-else statement down here, and the first block would show a good message. Correct serial key, well done. Whilst the else part will be showing the wrong serial key. So, whether you show right or wrong depends on IVAR2. So, we'll do the analysis in the next video. I'll see you then. Let's continue with the analysis. So we know that this is the correct function. We can rename it. Before we can rename it, we have to actually create a function because at the moment it is undefined. So to create a function, you need to go back to the place where this function is found, which is over here, the start of the push EBP. And how did I get here? I go to the string search, go back to the Unicode for the wrong message over here. And then I went back to the cross-reference, double-click on it, and I land back over here. Correct and wrong. If you want to see the rest on the three dots here, you can use this and click on the three dots. It will highlight the operand. You can drag, and now you can see the rest of the three dots. So now we have to look for the start of this function's. This whole thing is contained in the function. So you need to scroll up and look for the push EBP, which marks the start of this function. Push EBP. There you go. So once you have found the push EBP, you can recreate a function here by right-clicking and select Create Function. So now you have a function. And now you can double-click on this, go back to the decompile, and now you have a proper function rather than undefined function. So now you can rename it by right-clicking or pressing L on the keyboard and rename it. And we can call this we could rename it anything we like, actually. Right, let's now analyze this function. We will start from what we know. We know for sure that this var is important. It needs to be 0 in order to be correct. So, IVAR1 is probably an integer. We can rename it as result. And this result is coming from this function. This function is doing some kind of comparison, I believe, with IVAR2, PLVAR2. There seems to be a Windows 8BI get local time. So let's go to Google Chrome and look it up. Get local time. And probably this is the one that we want. Get local time. Let's check it out. So get local time will return system time to the parameter in which it is passed. And else's LP system time is a structure to receive current local data in time. All right, let's take a look. So that means we can rename local 30 to become system time. So this is called system time. So let's rename it. All right, so in system time now, we are doing some kind of operation with system time. You can see it here. All right, let's refer to the API once more and see what it does. In order to get a better understanding of what system time's structure, we need to enter this right-click. Open a new tab, and here is the further explanation on the what is system time all about. Vary year. The first member is year, second member is month, and so on. So what is it trying to do here, system time? It is performing a bitwise operation. So we can look it up. I've already got the page open here. And you can see bitwise binary right shift operator. The left operand's value is moved to right by the number of bits specified by the writer or printer. So, when we use this understanding with this, it means we are shifting by hex 10. Hex 10 is 16. 16. So, that means we are accessing probably, definitely not the first one. Probably we're shifting into the members here. So a word is supposed to be 2 bytes. 2 bytes or 16 bits. 16 bits. So, when you perform shift of 16 bits, that means you're accessing the second member. So one word is 16 bits. If you perform a shift operation of 16 bits, that means you are accessing the month. The month. So over here, you are shifting 16 bits to access the month. So local 7C could be the month. So let's rename it to month. So now you have month here. Let's click on month. And what is local 2C? Local 2C shifts 16. And we need to find out what is local 2C. So sometimes we don't get any clue by looking at the compiler. We can go back to the hinting view to get some more hints. And the other hint is the sprintf. I think this is sprintf because it takes this as a parameter to perform some kind of operation. So what is sprintf? If you look up the internet, search for sprintf, sprintf takes a list of format specifies to construct a string. So, for example, if you have this kind of format specifier, and you are using sprintf, you will put the target string here, followed by your format specifier, and then at the back, you will put all your harder strings here. like this. So in the end, you will get the tugger string, which is made up of string A, B, and D, and C, all lumped together in one new string. So if you had something like this, so in the end, your target string will end up become test dash, so dash, test dash, which is coming from here, and then followed by the 1, 1, coming from here, 2, 2 coming from here, which is B, and 2, 3 coming from here, which is C. So this is the meaning of format specifies. So this is a kind of format specify a string, integer, integer, integer. So in the end, your target string would be this. This would be your target string. So we can make some deductions by analyzing the code here. We know that the target string is like this, is this one. So this must be the target string. So we can just relabel this as target string. So your target string is an actual key. Might as well call it actual key. Actual key string. So we make assumptions like this and modify as we discover more data and more facts. That means this one must be sprintf. So we can relabel it as sprintf.
Like that.
So from this, we now can deduce that all the parameters above are the parameters that will be pushed to be used by this function. So we have month, we have local 78, local 60, which we don't know what it is. But we know for sure month, so month is one of the parameters used by this function. And if we are lost like this, sometimes it's good to go back to the listing view, the assembly view. So this is a part where you move parameters to sprintf, and this is where you call the function sprintf. So over here above will be all your parameters that are used by your expert. So we can see that one of the parameter is month. I'll just turn this off. One of the parameter is month. So we have 3 others. This one, DI, is typically used for storing strings. Probably this will be a target string, so we can just relabel this as target. Just edit label and call this target.
String.
And then this one will a month, so what are the other 2? A lucky guess would be year, month, and day. Year, month, day. So if we assume that this was year, we can call this year. We can edit this as year. And we can edit this to label this as day. So just change the label to day. It makes sense because month is extracted from, you can see here month extracted from the system time. So it makes sense that the other 2 is also coming from system time. So we can deduce that most probably all these 3 are coming from system time, and we can go back to system time to take a look. System time allows you to extract year, month, and day. All these 3 things like this. So we can, based on this and other evidence we have seen, it is a good deduction that probably this is day, month, and year. And how? And you can confirm the year further by looking at param 1. So when you look at param 1, parent 1 receives the pointer to the address of this structure. So the pointer to a structure is the first element of the structure usually. And what is the first element of a structure? Here. So parent 1 is actually a pointer to the here. So we can actually rename this parent 1, pointer
Ooh. System
time. And since it's a pointer system time, it also points to the year. Pointer, so we can properly relate this pointer to system time and first element. So element of the point of the structure is year itself. Right? So this makes more sense now. See that? So most likely we are right reducing that this is a year. Year, month, and day. And this one probably is the string. This one. This string. So this string is probably your name. Because when we go back and take a look at the grab me, it asks you for a name. There must be a reason why it wants a name. It's probably going to use it to create the serial key. And then when we see there's a string component here, we can more or less guess that this must be the name which you enter. So, and it requires a parameter for that. So parameter must be this. So now that we have examined again, we can relabel this based on new findings. So this is not target string. We can relabel it as name. Name string. So now this makes sense. You see, it makes a lot of sense. Name string goes to the S %format specifier. Year goes to the D here. Month goes to the other format specifier. And day goes to the last one. So this tells very well with our hypothesis. This we saw just now, that the S-punner coming from here, S-punning coming from here, which relabel, accepts all these parameters in this order. Okay, so based on this, we can more or less guess now what is our serial key. So the first parameter will be whatever you enter. So if let's enter test, then it will insert dash, then you insert year. So let's say today is 2 to 1, then you insert the month. Now is March, so March is 3, and finally the day. So today's date is 19. You can go up here and hover your mouse to confirm the night. So 19 March 2 to 1. Right? So now we're going to test is serial key and see if we are right. So I'm going to enter test here, and then serial key will be test, followed by dash 2 to 1, 3, and the 19th day. Yes. Correct. So now we are solved this. Crack me. So this is how you do analysis. Sometimes the compiler is not accurate and makes mistakes. So you have to read between the lines and then go and analyze the other things in the listing, refer online to the APIs like this, and then open up a notepad as a scratch pad to make your notes and test hypotheses. If your hypothesis is wrong, you redefine it, change it, and then test the hypothesis again. That's all for this video. Thank you for watching.